Today's video is a remake video of solving systems of rates. Apparently there was a huge issue with trying to solve systems of rates with the graphing calculator, so I'm going to go ahead and remake this using a different skill other than the calculator. You should always use the calculator to computate numbers, but for this particular problem there's a great skill that we can use to solve it fairly easily. Before we begin, remember that the distance formula, which is pretty much multiplying the speed something's going and the time that they've gone for together to figure out how long they've gone. Really, it's just y equals mx with more real world words. So anything that relates to distance is y, rate is slope, and time is x. So I'm going to go ahead and start reading this now. A truck leaves the garage at 12 a.m. So we have a truck leaving the garage. We don't know which garage, but we know it's leaving at 12 a.m. Here's time. Now, it's important to distinguish between this time and the time that's in the formula. The time in the formula refers to how long something has traveled for. This is time of day, so it's not a relevant time. And leaves at an average rate, there's the word that we're looking for, of 20 miles an hour. So that's an important piece of information for us. 7 hours later, now this is referring to 7 hours, that refers to time. A second truck leaves the garage to catch up to the first truck. So the first truck leaves 7 hours before the second truck, and then the second truck leaves trying to catch the first truck. So this word is kind of important, and you'll see why in a little bit. If truck 2 travels at an average rate, there's the word rate, of 60 miles per hour, then how long will it take before truck 2 catches up to truck 1? And how long right here, if you say it really fast, sounds like Chinese, how long? But it's really asking us for time, because this refers to time. Now, whose time is it asking us to find? Well, how long will it take before truck 2? So it's asking us to find truck 2's time. So we don't know truck 2's time. We can make our first unknown the variable x. Now, it's asking us not to round our answer. That's a great indication that whatever we get in the end is probably going to be a decimal. So now let's go ahead and create two equations based on the information that we know. The first equation is going to be based on truck 1. So what do we know about truck 1? Did it say anything about distance? It did not say anything explicitly about distance, but we know that this second truck is trying to catch up to the first one. So we know at the point that the two trucks meet, their distance has to be the same. So it didn't tell us a value for the distance, but we know that the distance of the two trucks is the same. So what we can do is, for truck 1, we can say that the distance for truck 1 is equal to the distance for truck 2 because it's a catch-up problem. So what is our slope going to be? When our slope is our rate, and that was actually given to us. It said that the speed of truck 1 is 20, so we can make our slope 20. And then our time for truck 1. Well, we're trying to figure out the time for truck 2, and we weren't given really information other than this 7 hours later for truck 1. So I'm going to actually come back to this and you'll see why in a second. Now I'm going to go ahead and set up the equation for truck number 2. Again, for the distance for truck number 2, we know that the distance is equal to the distance for truck 1. So we can just write y equals y. Now for the rate, we know for the rate we're going to put 60 because it was said 60 miles an hour was the speed truck 2 was going. And then for the time, that's what we're trying to figure out. So if we're trying to figure out truck 2's time and we don't know it, we'll just leave truck 2's time as x. Now let's go back to truck 1 and think about what we can put for truck 1's time. And this is going to be important as we try to figure this out. 7 hours later. Now there's a couple ways that we can set this up. Based on the way that I set it up, making the time for truck 2 just x, I've got to factor in this 7 hours later. So if truck 2 travels, let's say, for example, 2 hours, then what does that mean truck 1 traveled for? Well, if truck 1 is leaving and then 7 hours truck 2 leaves and only goes 2 hours, that means truck 1's time has got to be 2 hours at least, plus it left 7 hours before truck 2. So 2 hours plus 7 would be 9 hours. We know if truck 2 is leaving later, that this number means that the truck 1 left 7 hours before, right? So we're going to say that truck 1's time is equal to truck 2's time plus 7 hours. Because truck 1 left 7 hours before, so that means that truck 1's time is going to be more time, right? Now we can go ahead and set up our two equations, and I'm going to use a neutral color to do this. And now when I mean set up our two equations, what I mean is just put y equals mx all together. So the time for truck 1 is y equals the equation, the slope is 20, and then the time here is x plus 7, and when you write it, you're going to want to write it in parentheses like this. Now the equation for truck 2 is y equals the slope and the time we don't know yet. So now how we're going to solve this is fairly easy. Because the two trucks went the same distance, and we know that because of the word catch up, all we're going to do is take these two equations for y and set them equal to each other. So we're going to put 20 times x plus 7, which is the equation for the first truck, and make it equal to 60x. So we're just setting the y's, we're replacing the y's with our expressions and setting them equal to, because we know they went equal distance. Now that we have an equation with just one variable, we can go ahead and solve. So I'm going to simplify first by distributing this 20 into the parentheses. 20x, 20 times 7, well, you already know what I'm about to do. Whoops, that's definitely not it. Calculator. 20 times 7, no problem for me when I've got this handy thing right here. That's 140. Plus 140, super easy, equals 60x. Now we've got variables on both sides, so we've got to eliminate the variable on one side. It makes more sense to eliminate on this side, since this side has less numbers when we're solving. So we're going to go ahead and subtract 20x. That's the inverse here. We're going to do it to the other side. 20x minus 20x, that is 0x, which is just 0, plus 140 is just 140, equals 60x and minus 20x are like terms that we can combine. So 60 minus 20, clear this, 60 minus 20 equals 40, so we know that it's 40x. And now we can go ahead and divide, because that is the inverse of the multiplication, both sides. And I'm going to use the calculator once again. So we've got 140 divided by 40. So 140 divided by 40 equals, expression error. Why did that happen? Backspace. Let's try it again. 140 divided by 40 equals, why is it giving me expression error? I don't understand. Does it have to do with this thing? 140. Oh my gosh. Divided by 40 equals 3.5. So if that thing is on degrees, make sure that it's on radians. So we know that it is 3.5 equals 40 divided by 40 is 1. 1 times x is just x. So we've solved for x, and the x that we solved for was the time for truck 2. So we've actually found our answer because of the way we set it up. We don't have to do any more work. Now if I wanted to know truck 2's time just for funsies, truck 1's time, then I would add 3.5 to 7. That would give us 10.5. And I'm not going to put that in the calculator because we're done. Now let's do one more example, and I'm going to show you exactly how fast you can do this once you understand what you're doing. And I'm going to do this in just one color. So a truck leaves the garage at 1 a.m. We already know, we don't need to know the time. And travels at an average rate of 8 miles per hour. 10 hours later, a second truck leaves the garage to catch up to the first truck. if truck 2 travels at an average rate of 40 miles an hour, then how long will it take before truck 2 catches truck 1? So what do we know about the time or distance or rate for truck 1? Well, we know that the distance is the same because it's a catch-up problem, so we can just say y equals y. What do we know about the slope? It was told to us, 8 miles an hour. What do we know about time? Well, we don't know time yet because it's asking us to figure out how long. Now we're again trying to figure out the time for truck 2, so we're going to leave this blank for now. Now for truck 2, what do we know? Well, we know the distances are the same. It told us that the speed was 40. Does anybody find it interesting that the first truck is only going 8 miles an hour? I'm wondering right now if this guy is pushing his truck, because that is very slow for a truck. This guy obviously has a Silverado, so I'm going to go ahead and just write wagon and F-150. So we're trying to find the time for the F-150, and we don't really need to know the time for the wagon, but it's important to understand how to set this up. So since we're trying to find F-150's time, we're going to make the F-150's time X, and then the wagon's time. If the F-150 leaves 10 hours later, that means the wagon's time is the F-150's time plus 10 hours since it left 10 hours before. So this first guy should have more time. Now we can go ahead and set up our two equations. We've got for the wagon, we've got y equals 8 times x plus 10. And then for the F-150, we've got y equals 40x. Now that y's are the same, or the distances are the same, we can just set them equal to each other. So we've got 8x, or 8 times x plus 10 equals 40x. Now let's go ahead and solve. So first I'm going to distribute. We've got 8x, and then 8 times 10. I know what that is, so I'm just going to do it in my head. I almost made a mistake there. 8 times 10 is 80 equals 40x. Now let's choose the side that has just one number on it to keep the variable and eliminate it using inverse operations on this side. A negative number that is not being multiplied is obviously being, or a positive number that it's not being multiplied, right? It's being, we obviously know that it's being added in front, so we can go ahead and subtract. That is the inverse there. Do it to both sides. 8x minus 8x is 0, and 0 plus 80, well, plus 80 is just 80. These are like terms that we can combine. 40 minus 8, that I actually will put into the calculator. And the more I use this thing, the faster I get at it, so keep practicing it. Now we're going to go ahead and eliminate this since it's being multiplied because there's no operating sign. We can go ahead and divide. That is the inverse. I'm also going to use the calculator to do 80 divided by 32. So 80 divided by 32. And that gives us 2.5. So we know that this simplifies to 2.5. 32 divided by 32 is 1. And 1 times x is just x. So we found x, which we made truck 2's time. So we can say that truck 2 went for 2.5 hours. Well, how long did truck 1 go for? It went for 2.5 plus 10, which is 12.5. That is 2 examples, and you'll know that as soon as you can figure out how to set these up, which is pretty much the same every time, that it can go very, very fast. Make sure you use the calculator to do your computing.